Welcome. Thank you all for being here. I'm Meredith Lee. I use she, her pronouns. I'm a data instructor in the Arcus education team in DBHI. And today's talk is the final piece of our 5-part series on SQL or SQL. This webinar is being recorded, so please leave your cameras and mics off. And if you do have any questions that come up during the talk, feel free to put them in the chat. Also, feel free at the end to come off mute and ask any questions you'd like. We'll trim the recording so that you know, none of those will be posted anywhere. I will pause occasionally to check in the chat for any questions, and I have a couple of my colleagues on this call with me as well who may chime in. And so with all of that said, let's go ahead and get started. Let me get rid of this so we can see the slides a little bit better. So today, we'll be learning how to combine data from 2 or more interrelated tables into one data set using the join command. This is a hands-on webinar. We'll be writing some real SQL code today, but don't worry, we'll provide plenty of scaffolding when the time comes, and we'll work through everything together. In previous webinars in this series, my colleagues Rose Franzen and Elizabeth Drellick taught you how to write basic SQL queries using select, from, and where, and then to craft more complicated queries using case, like, group by, and some aggregate functions. Today, we'll first quickly review some of those commands, and then we'll learn how to combine data from multiple tables using the join command. Material for this talk is based closely on the Dart module SQL Joins, written by Joy Payton. We thank Joy for her work in developing this excellent content. And our webinar today may not cover all of the topics in the module. We may just not have time. So I suggest you check it out after the session. We're firm believers that the best way to learn is to practice. As I mentioned before, we'll have opportunities to practice writing our own SQL code today. There'll also be short quizzes to help you solidify your understanding as we go. And as a note, all of the tables you see and work with today all contain only fake data, even if they look realistic. And with that said, let's dive right in. So first, let's quickly review some key concepts from our previous 4 sessions. If you've attended those sessions or recently watched those recordings, some of this will be very familiar. But just as a quick reminder, SQL, or SQL, stands for Structured Query Language, and it's a specialized programming language that is used to interact with relational databases. Relational databases consist of many data tables, and today we'll be working with multiple tables that are stored in a single relational database. SQL is great at working with rectangular data, so data that is stored in tables with rows and columns or fields. Excuse me. However, it's not great. Excuse me. There we go. It's not great for statistical, linguistic, or data visualization purposes. So SQL is a tool that is often partnered with other tools that are better suited to those tasks, like R or Python. You may also recall that SQL has a variety of different implementations or flavors. While those flavors all have a similar structure and the same basic syntax, each can have differences in the availability of certain functions, as well as the type of error messages you might see. There will be times later in this webinar when I'll point out that the flavor of SQL we're using today is impacting how we need to write a query. Knowing the specific flavor of SQL that your database uses is especially useful when you're troubleshooting. In the hands-on portion of this webinar, we'll be using Alice SQL, which runs right in your browser. All right. So before we learn any new SQL commands, let's do a quick review of the commands select, from, and where that we learned about a couple of months ago. So to select only the columns or fields you want, you use a select statement. Select specifies the columns you're interested in, and from specifies the table or tables those columns are from. Makes sense. As a reminder, we recommend using dot notation and comma first style to list the specific fields you want to see. This is just a stylistic thing. SQL doesn't matter, but it makes your queries easier to edit. The where clause, using the where keyword, is the section of your query used to specify any filtering logic that should be applied to your query before returning any output. It's optional, but often very useful. As an example, here is how you would filter the output to include records for a specific county, Suffolk County in this case. So in the previous webinar in this series, we learned other keywords such as distinct, case, like, group by, and having. We won't need to use those today, and so we're not going to review them here. But if you need a review of those keywords or any other topic we've previously covered, please see our previous webinar recordings. So let's talk about joins. Up to now, we've been working with data from only one table at a time, but SQL databases are made up of many tables, and often the questions you want to answer will require referencing more than one table. This is where SQL join functionality and the join keyword come into play. So this is what a SQL join looks like. As we go on today, we'll be breaking down the code for a SQL join into its distinct parts and discussing those parts. So why joins? Excuse me. Let's consider the case where you have data in a multi-site studies research subjects, or data about them, those subjects. One table holds depression scores for subjects, and a different table holds subject addresses. Your hypothesis is that people who live in certain zip codes have higher rates of depression. To see if your hypothesis has evidence to back it, you need to combine data, taking the subject ID and depression score from one table, this depression scale table, and the subject ID and zip code from another table, the subject address table, and combining them so that you get matching information in the same row of the same table. So maybe your source tables look something like this. And the result should be a single table that might only have 3 columns: subject ID or subject ID, dep total, so your depression score here, and zip. That way you can more easily look at the relationship between depression inventory scale and zip code. So how do we go about creating a join? Well, there are 2 basic pieces of information you'll need to know to write successful joins. The first is the type of join. The type of join shows up in SQL in a from statement. Let's say you have some students with math grades in a table that you might call math grades, and some students with language grades. And those grades are contained in a table that you might call language grades. Some students are only in the math grades table, some are only in the language grades table, and some are in both. So what part of the overlapping data do you want? Only the data on students that with both kinds of grades, or some other larger set of student data? The answer to this question will determine what type of join you choose. The second is join criteria. The join criteria shows up in SQL in an on or using statement. When thinking about join criteria, we want to know what constitutes a match of data from one table to data from another. If you're joining tables that hold student grades, for example, you probably only want to join data together where the student ID matches. So it can be surprisingly tricky to figure out what data match or go together in your join criteria. If we take a look at the tables on the previous slide, and I'll go back to the previous slide in a moment so that you can look at this, what data would be considered matching between the depression scale table and the subject address table? Let's go back and look. So I'll just reiterate, if we look at these two tables, what data would we be considered matching between uh, depression scale and subject address? Let's all quickly take a couple of moments and just write quickly what you think in the chat. We're going to go over this together in a moment, so don't worry. But just what's your first thought? All right, we've already got some stuff coming in. I'm seeing a couple of folks saying subject ID. Any other thoughts? All right, well, it seems like we have agreement. Aha, yeah. All right, so we all seem to agree that subject ID is an important criteria for matching. But is the answer just as simple as matching on subject ID? And in this case, it probably isn't. And that's because subject ID 11234 is associated with two addresses at different times. And so you need to include date in your join criteria as well, so that you have the zip code of the subject when the depression scale was administered. If this is a little confusing, don't worry, we're going to come back to this idea in a later example. All right, we already went through this slide. Let's talk about combining join type and criteria. So this is the basic structure of a SQL join, including the type of join and the criteria that we're using to match data across Table 1 and Table 2. For the rest of this webinar, we'll talk first about about join types, then join criteria, and then we'll finish up with more examples to help you understand how these two elements of a join work together to give you the results you care about. So your SQL join might look something like this. In your select statement, you might select all of the fields from table 1. So recall that your asterisk here means all of the fields. And a couple of fields from table 2, ICD 9 and the X date. A from statement, and in this case it is a left join that we want. We'll talk more about join types in a moment. And you can see our join is in our from statement and our join criteria. So where Pat ID in table 1 matches Pat ID in table 2. So first, let's talk about join types. Let's consider the gradebook example we mentioned earlier. We might have two tables, one called math grades and one called language grades. Some students appear in math grades, some in language grades, and some students have rows in both tables. This can be represented by a Venn diagram where the left circle represents a group of students who appear in the math grades table, and the right circle represents the group of students who appear in the language grades table. And there, as you can see, is some overlap between these two circles, representing the subset of students who appear in both tables and who have grades for both subjects. There are four basic join types, and we're going to talk about those now. And as we go through these, the data that you want to capture with each type of join is represented in blue. So there's an inner join, which represents where only the middle or overlap is highlighted. A left join, where the entire left circle is highlighted, including the overlap. A right join, where the entire right circle is highlighted, including the overlap. And a full join, where everything is highlighted. And so we're going to talk about these types of joins in more detail, and we're going to start with inner joins. Here is an inner join. And this is the default behavior of the join keyword without any modifying words. And it finds matching grade data falling in the both math and language grades overlap section. So this intersection right here. This is often the data you want to capture. And if you're conducting a research on the correlation between math and language grades, this is the join you want. If a student lacks one or the other grade, their data isn't useful to you, and so you don't want it. The result of an inner join will be a table that has only rows of data for students who appear in both tables. If a student is missing in one or the other table of grades, that student won't appear in your results set. An inner join shows up in code like this. And you can note here that the word join itself means inner join. You can use either. You can say either inner join or just join. And I'll reiterate this because it is very, very important. That an inner join is the default behavior if you want to use join. So be certain this is the type of join you really want. So if you only use the keyword join, it is an inner join. Next up is left joins. Again, let's consider the left table to be math grades and the right table to be language grades. A left join, or a left outer join, as you'll sometimes see it, finds unmatched data in only math grades, that is, this outer part on the left, and also finds matching data in both math and language grades, this inner overlap section. It would exclude student data in the only language grades section, this unhighlighted portion on the right. Maybe you want this data because as a chair of the mathematics department, you want to see what students are strongest in math and also in language, if known, in order to select who to award a math prize to. Perhaps you'll use language grades as a tiebreaker, for example. The result of a left join is a table which contains rows of data for students who only have math grades and therefore appear in the left table, as well as rows of data for students who have math and language grades and therefore appear in both tables. But no rows of data for students who only have language grades. When there's no matching data from the language table to join to the data from the math table, because the students don't have language grades, these cells in the table are empty or null. A left join shows up in code like this. Note that one table is listed first and is therefore on the left, and the other table is listed second and is therefore on the right, because English is written left to right. Note that unlike an inner join, you'll always need to specify that you are using a left join, though depending on preference, this outer keyword isn't necessary. So you can use either of these. Right joins. A right join, or a right outer join, finds unmatched data in only language grades, that is, this outer right part of the Venn diagram, and also matching data in both math and language grades, this inner overlap section, and would exclude student data in only math grades, which is on the left. So this unhighlighted section. In this case, maybe you want this data to create a graph of language grade distribution and want to enrich it with some statistics about math grades where they're available, but it doesn't matter if some students lack math grades. The results of a right join is a table which contains rows of data for students who have only language grades and therefore appear in the right table, and rows of data for students who have language and math grades and appear in both tables, but no rows of data who have only math grades. When there's no matching data from the math table to join with the data from the language table because the students don't have math grades, these cells in the table are empty or null. A right join shows up in code like this. Recall that right and left refer to the order in which the table names are typed in the from statement, with math grades being our left table and language grades being our right table. Now, some of you might have clocked that because left and right tables just refer to the order that we write our tables in this from statement, that the fact of whether it is a right or left join seems arbitrary, and you would be right. In fact, you may not see a lot of right joins in the wild, and that's because many people who write SQL code simply prefer to use all left joins. It's simple preference, it's not correct or incorrect, and this is because right and left simply refer to the order in which the tables are written in the from statement. You can rewrite a right join into a left join by switching the order of the tables in the from statement. And so you can always choose whether you want to use a right or a left join. And this is often a left join by convention. And finally, let's talk about full joins. A full join, or sometimes you'll see full outer join, will consider all of the data, all of the outer unmatched data on the right and left tables, as well as the inner overlapping data that has matching data from both tables. This kind of join is important if you want to create, perhaps, a gradebook that shows student grades for each student, including their math grades and or their language grades. The result of a full join will be a table that has rows of data for students that have only math grades, students that have only language grades, and students who have both grades and therefore appear in both tables. When there's no matching data from one of the tables to join with the data you included from the other table, for example, a language grade for a student who does not appear in the language grades table, null values or empty cells are added. A full join shows up in code like this. You can specify a full outer join, but full join means the same thing, and which you choose will come down to preference. All right, and let us do our first little quiz, and I'm going to bring up a uh, a poll, and we can test our understanding a little bit. All right. So we're going to consider the scenario of a table of math grades for ninth grade students and a table of language grades for those for ninth grade students. Some ninth graders appear in both tables, but some only appear in one. Fatima appears in the math grades table, but not in the language grades table. When you perform a full outer join on these two tables, what will happen to Fatima's data in the resulting joined table? And you have 4 options here. And let's take a moment, answer this question, and then we'll come back together and discuss the answer. Right, we've got some Some answers already coming in. All right. Great. All right, let's go ahead and discuss this together. So our options were that her data would not appear since she's not represented in both tables. This wouldn't be correct because we're doing a full outer join. Her math grade will appear and she'll have a blank for her language grade. That seems promising. The join command will fail because a full join can only take place on fully overlapping tables. This is not the case. The join command will fail because there's no such type of join as a full outer join. We just learned about full outer joins. And so I think we can agree that this is the correct answer. And it is. So in this case, Fatima's data will appear in the results because regardless of whether the math grades table is written on the left or the right, a full outer join includes both the left and right tables data. Her math grade appears in the math grades table, so that will appear. But since Fatima has no language grade in the language grades table, she'll have empty cells with null values for any columns that come from the language table. All right, I'm going to pause briefly for some questions. So if you've got anything you'd like to ask about now, post them in the chat. And yes, I see there is a question about how to save saved tables into a new database. And yes, we're not covering that today, but hopefully we can get you some answers for that. And thank you, Rose and Elizabeth, for tackling that question. All right. Okay. And let's move on to join criteria. So the second component of a SQL join, which you'll need regardless of the join type, is the set of conditions by which rows from two different tables are said to match, called join criteria. Join criteria will be some sort of relationship statement referencing data that occurs in both tables that you want to join. This relationship statement will be evaluated to true or false when your join is executed. So as a reminder, a SQL database is a relational database, so it's not surprising that we talk about data relationships here. So if, for example, you had two tables, depression scale and subject address, you might want to match on the common field subject ID. Similarly, if you had two tables, items and orders, you might want a subset of data from these two tables, but only where the item ID is the same. You can also have more than one condition to match on. Excuse me. In this case, perhaps we want not only to match the student IDs between the two tables, but the semester as well. Excuse me. Went a little bit too fast. When the conditions in your join criteria evaluate to true for a row, then a join will be performed for those rows. And when the join criteria are evaluated to false, no join for those rows will take place. Often the relationship is equality, such as in these examples, and that's when you're looking for a perfect match between your two tables. Though this isn't always the case, as we'll see later. So equality is the most frequently used condition for joins, and that's when you're looking for matches between two tables. For instance, do you have subject identifiers or student ID numbers in two different tables? The shared information can be used to join data from these two tables based on the identifier being equal. We've already seen a few general examples of criteria based on equality, but now let's look at some tables and how we might express our criteria in SQL. So for example, um, if the subject ID matches a row from the diseases table and a row from the smoking uh, table will be joined. If the subject ID doesn't match, these rows won't be joined. I'll have to scroll down a little bit to see our SQL code. Maybe we're trying to match lung cancer occurrence and smoking exposure in the same row. In the code, we usually use an on statement to do this, though we can instead use a using statement, as you can see here. In this case, we're comparing the equality of two fields that have the same name. And so we can also use the using keyword. This special word only applies when you're looking for a perfect match between fields that have matching names. It's okay if you never use using and prefer to always stick with on, which is more multi-purpose. You can see that using is a little bit shorter as long as the field names are the same. But often you'll just see on because it's multi-purpose and you don't have to worry about remembering how to use using. But with either of the above code snippets, on or using, subject 3 from disease matches with subject 3 from smoking. Subject 5 from disease doesn't match with anyone in smoking. Subject 8 from disease also doesn't match anyone from smoking. Subject 2 from smoking doesn't match with anyone from disease. And subject 4 from smoking also doesn't match anyone from disease. Sometimes the data that appears in the two tables has the same field name as we just saw, but sometimes the data might be stored under different names. Here's an example in which the same data, semester in math grades and term in language grades, is labeled differently between the two tables. Luckily, SQL can handle this. In this example, the A grade for January through May 2023 from math grades matches with the B grade for January through May 2023 in language grades, even though the subject ID doesn't match. If we're using semester and term as our join criteria, these two match. And the C grade for September through December 2022 in language grades does not match with any row in math grades. This also highlights the importance of documenting your data so you can tell which fields hold which data in order to use them properly. If semester and terms are different things and not just the same thing with two different names, the result of your join will be disappointing. This also shows that figuring out your join criteria requires close attention. We probably don't actually mean to match student 11's math grades with student 14's language grades. Sometimes you don't need equality as your condition. So let's look again at our example from earlier of our multi-site mental health research. And let's say we want to associate a particular depression score with a particular address only if the depression inventory was given between the start and end dates of residency at that address. Recall a few slides ago when we asked if subject ID matching was enough? This is the other part. So in this case, in our on statement, we have said that we want our date to be between the date of start and the end date of residency. But we still probably want subject ID to be considered. So we can also have multiple conditions. So we'd want to make sure that there was a match on subject identifier. We don't want to match Lakshmi's depression score with Larry's address just because the dates worked. You can combine conditions too. So here we're looking for an exact match on subject ID and a date match that is between the correct dates. So let's get even more complicated. Let's keep thinking about our depression inventories and our goal of matching depression scores to addresses in our study. Excuse me. What if some addresses don't have end dates? This could be because the subject is currently still living there. We can see in our data that there are some addresses with null end dates. You scroll down, we've got a couple of them here. So this is something we should account for. You can create arbitrarily complex Boolean logic or Boolean algebra using and, or, not, and parentheses as needed. Much as in math, there's an order of operations to this kind of logic, and you might need several sets of parentheses to make sure you're applying the conditions correctly. For example, in this query, we've used a few instances of Boolean logic, and we've added some comments to help illustrate the logic. So with this most recent join criteria, the depression score, dep total, for subject 11234, measured on 2021-5/15, matches with the address 123 Oak Lane for the same subject and time period, the second row in the subject address table. However, this same depression score will not match with the address 123 Main Street for this subject, the first row of the subject address table, because the time period doesn't match. The other rows in the depression scale table don't match with any rows in the subject address table, and the first and third rows of the subject address table don't match with any rows in the depression scale table. Okay. Let's do another quick poll. Okay. True or false, a matching ID, like student ID or patient ID, is always sufficient as a join criterion. True or false? We'll just give you a couple of, probably just about a minute to do this. All right, we're getting a lot of responses, a couple more seconds, and we'll go through the answer. Okay. Let's go through this together. All right, most of you got it exactly right. The answer is false. So often, a matching identifier is part of what makes up good join criteria, but it may not be sufficient on its own. For example, consider trying to link patient diagnoses with medication orders. Patients can appear dozens or hundreds of times across decades. And so to correctly link diagnoses with medications, it's not sufficient just to rely on patient ID. You may need to use an encounter ID, a date range, or another join criteria to make sure you're matching data that really belongs together. Instead of joining Mary's diagnosis of diaper rash when she was 3 months old to her prescription for Ritalin at age 9. Okay, and I'm going to take just a moment to pause and see if we've got any questions. All right. All right, well then let's keep going. Now we're going to combine everything, and we'll get a chance to use these two parts of SQL joins, put them together, and craft some queries. We'll use from statements to describe the type of join and an on statement to describe the join criteria. Don't worry, we'll add plenty of scaffolding in the beginning and slowly work up to crafting an entire SQL join from the ground up. But importantly, we're only going to present a few examples. There are many combinations we can consider at all levels of complexity, and we won't have time to cover all of the possibilities today. Instead of being exhaustive, we've concentrated on the most frequent use case you'll encounter over and over, equality. We'll go over each join type, inner, left, right, and full, on a simple equality matching to a single field from each table. All right. It is your turn. And I think we're going to paste a link into the chat. So to understand what an inner join with equality looks like and acts like practically, let's perform an inner join on these two tables. To do this, you'll have to combine join criteria, subject ID matching, with a join type, in this case, an inner join. Excuse me. So you're studying the link between lung cancer and smoking behavior. Let's perform an inner join on these two tables, matching on subject ID. Remember, with an inner join, we only want subjects for which data are present in both tables. For this example, the join criteria is already written for you, but we need to add the join type. You'll need two table names separated by some kind of join command. So for now, leave the on statement unchanged. But think about what rows you expect to see in your results set before you run any code. And when you want to see the results of your code, click the play button below the code block. Return here when you're done, and we'll work through the answer together. And I'm going to copy and paste something into the chat. And if you would just like or otherwise respond to this comment when you are finished, I'll wait till we have quorum and then and we'll go through the answer together. Give it just another minute or so, and then we'll come back together and go through it. Don't worry if you've gotten a little stuck. We're going to go through the answer together. All right. Sake of time, let's all come back together. We'll go through this. We've got a couple of more examples to go through, so you'll have plenty of opportunities to practice. Okay. So in this example, our select and on statements are already done for us, but we need to specify the type of join that we want. And we know we want an inner join, right? So I'm going to delete these. And let's consider our two tables. We know we have disease and smoking. And so with a join, we know we need the names of our two tables linked by some kind of join command, some keyword. So I'll list disease here. For an inner join, it doesn't matter which is considered your right table and which is your left. You only want the intersection. And as you may recall from the beginning, the default behavior for the join keyword in SQL is an inner join. So I can just write join and then my second table, smoking. And so we have here select all from disease, inner join or join, smoking, on disease dot subject ID equals smoking dot subject ID. So we want the subject IDs to match. And if I run this code, I get what I'd expect, which is one row of subject ID 3 and their data from the disease table where lung cancer is true, and their data from the smoking table, smoking pack years 10. And we would only expect this one row of data because this is the only subject ID that occurs in both tables. And because this is an inner join, you just want that intersection. Okay, so let's try another one. We're going to practice a left join this time. This time, you'll need to add both the from and on code sections into your SQL code. For now, just use on. Don't try using just yet. And for this join, it is important to specify which table is your left table and which is your right. So in this case, let's make disease the left table and smoking the right table, still matching on subject ID. And when you are finished, you can like this comment in the chat. So just delete these dots in the from and on and replace it with the SQL. All right. Just gonna give it another minute or so, and then we'll come back together. I want to make sure I get all of you out by 1 o'clock, so. All right. Let's go through this together. So this time we need to fill out our from and on. I'm going to start with my from statement. So like we said, we want disease to be our left table. And so we'll list it first because English is written left to right. So if we write it first, that is our left table. And we want a left join. And so the keyword is left join. And our right table is smoking. This time we need to write our on statement. But as we recalled, just like last time, we wanted to match on subject ID. So I need to let it know that I want subject ID from disease to match the subject ID from smoking. Oops, here we go. And I would expect from this, if you recall a left join, it's going to take, the result set is going to include unmatched data from our left table, in this case disease, as well as data that appears in both tables. So I'm expecting 3 rows of data in our table, which includes subject ID 3, which is our intersection, as well as 5 and 8, which only appear in our left table or our disease table. Let's see if that's true. And it is. So we have all of subject 3's data from both tables, as well as subjects 5 and 8, their data from the left table, and empty cells where they don't have data in the right table. Okay. And let's quickly, in the last few minutes, do the same thing, but practicing a right join. This time, your select statement is still done for you, but you'll need to add the keywords as well as your join type and criteria. And if you'd like, you can try using rather than on. But note that in Alice SQL, you have to write using without parentheses. And if you don't want to bother with worrying about that, go ahead and use on. And we're probably just going to give a minute or two to do this because we are almost out of time. All right, so like the last couple of minutes, let's come back together and we'll work through this. So this is going to look similar to our left join example, right? Except this time we don't have the helpful keywords already written for us, but we might recall that our join type in SQL is going to be in a from statement. So first we'll need from our left table, still disease, right join, since we're practicing right joins here, smoking. And then I'll use using here just to demonstrate it. Because subject ID is named the same thing in both tables, we can use using. And now I can just say subject ID. But you can use an on statement here if you'd like. And this time I still end up with three rows, just like the left join, except in addition to our overlap, which is again subject ID 3, we have unmatched data from our right table, excuse me, smoking, with empty cells in the columns in which they don't have data. So because subject IDs 2 and 4 don't appear in disease, they have null values for those columns. And we have one more example, but I'm going to leave that as an exercise for you to work through on your own, since we are out of time. I want to thank you all for joining us today. I highly recommend you go in and practice some of these things. If you look at the slides, we have a few additional resources, as well as some upcoming sessions. This is the end of our SQL series for now, but we have some interesting R sessions coming up. And so we'd love to see you there.